NENOMATICA, where mathematics meets YouTube excellence. In this lesson, we build an intuitive picture of angles and angle units. We'll see what an angle is, what positive and negative angles mean, how degrees and radians connect, and we will work through a few quick examples, including coterminal angles. An angle is created by rotating a ray about its vertex. Let's draw a circle and a ray at the origin. The ray starts along the positive x-axis. The amount of rotation is the size of the angle. By convention in trigonometry, counterclockwise rotation is positive and clockwise rotation is negative. Watch the green counterclockwise arc for a positive angle and the red clockwise arc for a negative angle. Angle units. A full turn is 360 degrees, which equals 2 pi radians. From that we get the conversion rules. Multiply degrees by pi over 180 to get radians, and multiply radians by 180 over pi to get degrees. Let us convert two angles. First, 315 degrees. Multiply by pi over 180 to get 7 pi over 4 radians. Second, negative 45 degrees. Multiply by pi over 180 to get negative pi over 4 radians. In this short lesson, we will use a circle to build intuition for angle measurement units. We'll see what a degree is and how it relates to a full turn. Step 1. 3 commonly used units for angles are degree, grad, and radian. Degrees cut a circle into 360 equal parts. Grads cut it into 400 equal parts. Radians measure angles by arc length relative to the radius. Let's place the 3 units side by side. Step 2. A degree is defined by dividing a full circle into 360 equal slices. We'll draw a circle, add compass marks every 30 degrees, and then highlight a tiny 1 degree slice. Step 3. 1 degree is exactly 1/360th of a full turn. Let's write that clearly and also connect it to other units. Quick visual check. A right angle is 90 degrees, which is 1/4 of a full turn. We'll shade a 90-degree sector to see it. We'll shade a 90-degree sector to see it. Finally, let's let a pointer rotate once around the circle to reinforce that a full turn corresponds to 360 degrees. Key takeaways. 1 degree is 1/360 of a full circle. A complete revolution is 360 degrees, which also equals 2 pi radians and 400 grads. Great job building an intuitive picture of angle units. In this example, we will measure 3 key angles on a circle. We will find the size of a right angle, the size of a half turn, and the size of a full rotation. Step 1. Determine the measure of a right angle. A right angle is 1/4 of a full circle. Let us draw a circle with a radius line to the right and a second radius up. The arc from 0 degrees to 90 degrees is 1/4 of the circle. 1/4 times 360 degrees equals 90 degrees. Step 2. Determine the angle to traverse half a circle counterclockwise. We return to the circle diagram. The arc from 0 degrees to 180 degrees forms a straight angle, which is exactly half the circle. 1/2 times 360 degrees equals 180 degrees. Step 3. Determine the measure of a full rotation. A complete trip around the circle brings us back to the start and measures 360 degrees. Therefore, a full rotation equals 360 degrees. Summary. A right angle measures 90 degrees. A straight angle, or half circle, measures 180 degrees. A full rotation measures 360 degrees. We will solve a trigonometry unit conversion exactly following the algorithm shown. Convert degrees to minutes, convert seconds to minutes, then add. We'll present the example, and then work through each step with rule boxes. From the source, the note reminds us how degrees relate to radians and how minutes and seconds subdivide a degree. 1 degree equals pi over 180 radians. Also, 1 degree equals 60 minutes, and 1 minute equals 60 seconds. We will use this conversion rule throughout. 1 degree equals 60 minutes, and 1 second equals 1/60 minutes. Step 1. Set up the conversion. We will convert the degrees to minutes and the seconds to minutes, then add the existing minutes. Step 2. Convert the degrees to minutes. Using the rule 1 degree equals 60 minutes, 37 degrees becomes 37 times 60 minutes. Step 3. Convert the seconds to minutes. Using the rule 1 second equals 1 over 60 minutes, 15 seconds becomes 15 over 60 minutes. Step 4. Combine all parts entirely in minutes. Degrees in minutes plus the given minutes plus the seconds in minutes. Step 5. Compute the product and the fraction. 37 times 60 equals 2,220. 15 over 60 equals 1/4 or 0.25. Step 6. Add them together. 2,220 plus 25 plus 0.25 equals 2,245.25 minutes. Quick challenge. How would you convert this result back to degrees and minutes? Hint, divide by 60. Final answer. The angle written entirely in minutes is 2,245.25 minutes. Great job, following the exact algorithm. Summary. Convert degrees to minutes by multiplying by 60. Convert seconds to minutes by dividing by 60. Then add. Practice converting between degrees, minutes, seconds, and radians using pi over 180. We begin with an example on angle measurement units using gradients. First, we display the word example. Then we state the problem in bold orange latex. The task is to read, extract, and present the definition of the Gradian unit and its metric subunits exactly and step by step. 1. A full circle is divided into 400 equal parts. Each part is 1 gradian. 2. 1 over 400 of a full turn makes 1 gradian. 3. The symbol open parenthesis g, our close parenthesis, is used. 4. Subunits are decigrad, centigrad, and milligrad. Step 2. Structural analysis. We will follow the exact order. Definition, formula, and subunits matching the source text. Now, the step-by-step solution. Step 3, the definition. We place a rule box stating, a full circle is divided into 400 parts. Then we draw a circle and highlight a tiny sector representing 1 gradian, which is 1 over 400 of a full turn. Quick challenge. How many gradians are in a right angle? Think before answering. The answer is 100 gradians. Step 3b, the formula. We place a rule box with the formula 1 gradian equals 1 over 400 of a full turn. We also remind that a full turn equals 360 degrees equals 2 pi radians. Step 3c, the metric subunits. We display a rule box listing decigrad, centigrad, and milligrad. Great job completing the steps. This summary is consistent with the source structure, definition, formula, and subunits. Welcome! In this video, we will extract math from an image about radians, follow the exact structure, and build a clear, step-by-step solution. We'll also visualize the geometry behind radians. Let's begin with the example label. Step 1. The key mathematical lines detected are the circumference, the radian definition as arc length divided by radius, and the 2 conversion formulas. We now list all extracted formulas. Step 2. Structural analysis. We will follow the original order. 1. Circumference of a circle. 2. Define 1 radian. 3. Relate a full circle to 2 pi radians. 4. Convert radians to degrees. And 5. Write the 2 conversion factors. Now, we begin the guided solution. Step 3. Define the circumference of a circle. The circumference equals 2 pi times the radius. Step 4. Define 1 radian. The angle in radians equals arc length divided by radius. When the arc length equals the radius, the angle equals 1 radian. Step 5. Relate circumference to a full turn in radians. A full circle angle in radians is the circumference divided by the radius. That gives 2 pi radians. Step 6. Convert radians to degrees. A full circle is both 360 degrees and 2 pi radians. Therefore, 1 radian equals 1 over 2 pi times 360 degrees, which simplifies to 180 over pi degrees. Step 7. Summarize the 2 conversion factors explicitly. We state 1 radian equals 180 over pi degrees, and 1 degree equals pi over 180 radians. Quick challenge. What is 90 degrees in radians? Pause and think. It should be pi over 2 radians. In this lesson, we will convert angles from degrees to radians using one clear 3-step algorithm. We'll follow the exact same structure for every angle. First, here is the example and the problem statement. We'll rely on 3 rules. Step 1. Write theta degrees as theta times 1 degree. Step 2. Replace 1 degree with pi over 180 radians. Step 3. Simplify the fraction. Angle 1, 40 degrees. We will follow the structure exactly. Step 1. Write equals parenthesis 40 close parenthesis 1 degree. Step 2. Replace 1 degree with pi over 180 radians. Step 3. Simplify to 2 pi over 9 radians. Angle 2, negative 270 degrees. Step 1. Equals parenthesis negative 270 close parenthesis 1 degree. Step 2 equals negative 270 times pi over 180 radians. Step 3. Simplify to negative 3 pi over 2 radians. Angle 3, 135 degrees. Step 1. Equals parenthesis 135 close parenthesis 1 degree. Step 2 equals 135 times pi over 180 radians. Step 3. Simplify to 3 pi over 4 radians. Example. The angles below are expressed in degrees. Write them in radians. We will follow exactly the 3 written steps shown in the worksheet for each angle. First, write the degree as a multiple of 1 degree. Second, replace 1 degree by pi over 180 radians. And third, simplify. Now we start with 45 degrees. Step 1 equals 45 times 1 degree. Step 2 equals 45 times the quantity pi over 180 in radians. Step 3 simplifies to pi over 4 radians. Next, 150 degrees. Step 1 equals 150 times 1 degree. Step 2 equals 150 times the quantity pi over 180 in radians. Step 3 simplifies to 5 pi over 6 radians. Finally, 240 degrees. Step 1 equals 240 times 1 degree. Step 2 equals 240 times the quantity pi over 180 in radians. Step 3 simplifies to 4 pi over 3 radians. Recap. The conversion factor is 1 degree equals pi over 180 radians. So, multiply the degree measure by pi over 180 and simplify. Our final results are pi over 4, 5 pi over 6, and 4 pi over 3 radians. Welcome! In this lesson, we convert angles from radians to degrees using one simple idea. Multiply by 1, written as 1 radian equals 180 degrees divided by pi. Then we simplify. Here is a quick picture for intuition. 1 full turn is 2 pi radians, which is also 360 degrees. Half a turn is pi radians, 90 degrees is pi over 2, and so on. The conversion rule. Because 1 full turn is 2 pi radians and 360 degrees, it follows that 1 radian equals 180 degrees divided by pi. To convert, multiply the radian measure by that fraction. Example 1. 3 radians. Write 3 radians as 3 times 1 radian. Now substitute 1 radian equals 180 degrees over pi. That becomes 540 degrees over pi, about 171.9 degrees. Example 2. 9 pi over 2 radians. Multiply by 1 radian equals 180 over pi. The pi cancels, and we get 810 degrees, which is 2 full turns plus 90 degrees. Example 3. 3 pi over 2 radians. Again, multiply by 180 over pi. We obtain 270 degrees, pointing straight down on the circle. Example 4. Negative pi over 6 radians. The negative sign carries through the conversion. We get negative 30 degrees. Example 5. Pi over 3 radians. Multiply by 180 over pi to get 60 degrees. Example 6. 11 pi over 6 radians. The conversion gives 330 degrees, a quarter turn shy of a full rotation. Summary. To convert radians to degrees, multiply by 180 over pi. Try this one on your own. 5 pi over 4 radians. Pause and compute it. The answer is 225 degrees. Great work today. Example. We will find the central angle in radians for an arc whose length is 1/6 of the circle's circumference. We'll follow a clean 4-step plan, matching the proportion method shown on screen. First, let's build an intuitive picture. Here's a circle with radius L. We'll highlight an arc that is exactly 1/6 of the circumference. The central angle that subtends this arc is unknown. We'll call it x radians. Step 1. The circumference of a circle of radius L is 2 pi L. Step 2. One full turn around a circle corresponds to an angle of 2 pi radians. Step 3. We now set up a direct proportion because arc length is proportional to the central angle. We'll pair arc lengths with their corresponding angles. Step 4. Cross multiply and solve for x. Now simplify by canceling common factors. That leaves 1/6 times 2 pi. The result is pi over 3 radians. For intuition, an arc that is 1/6 of the entire circle corresponds to 1/6 of the full angle. Since the full angle is 2 pi, 1/6 of that is pi over 3. Let's highlight the 60-degree sector on our diagram to reinforce the idea. Final answer. The central angle is pi over 3 radians. In this lesson, we will derive the conversion formula between degrees, grads, and radians. Our goal is to prove that d over 180 equals g over 200 equals r over pi. We start with a circle of radius r and a central angle theta, labeled AOB. We mark the radius, the two radii to points A and B, the arc AB, and the central angle theta. Step 1. Relate the angle in degrees to the arc length. A full circle measures 360 degrees, and its circumference is 2 pi r. We write the proportion. Arc length over circumference equals angle over 360 degrees. For an angle d in degrees, arc AB equals 2 pi r times d over 360, which simplifies to pi r d over 180. Step 2. Grads. In the Gradian system, a full circle is 400 grads. Our proportion becomes arc length over circumference equals g over 400. So arc AB equals 2 pi r times g over 400, which simplifies to pi r g over 200. Step 3. Radians. A full circle has 2 pi radians. So arc length over circumference equals r over 2 pi. Then arc AB equals 2 pi r times r over 2 pi. The 2 pi cancels, leaving our times r. Finally, the arc length AB is the same physical length in all three descriptions. We set them equal, and then divide by the common factor pi, r where appropriate. This yields the conversion identity. D over 180 equals g over 200 equals r over pi. Welcome! In this example, we will learn a practical algorithm to convert angles between degrees, grads, and radians. Then we will build a quick reference table and a clean unit circle to anchor the ideas. Here is the core relationship you should remember. Degrees divided by 180 equals grads divided by 200 equals radians divided by pi. From this single line, every conversion formula falls out immediately. Let us isolate each pair. First, degrees and grads. D over 180 equals g over 200. Cross multiply to get d equals 9/10 g, and g equals 10/9 d. Second, degrees and radians. D over 180 equals r over pi. Solving gives d equals 180 over pi times r, and r equals pi over 180 times d. Finally, grads and radians. G over 200 equals r over pi, so g equals 200 over pi times r, and r equals pi over 200 times g. Let us apply the algorithm to a concrete number. Convert 150 degrees into radians and into grads. To get radians, multiply by pi over 180. That yields 5 pi over 6. To get grads, multiply by 10/9. That produces 166.6 repeating grads. A tiny reference table of common angles is incredibly handy. Memorize these degree to radian pairs for instant recall. Now let us anchor everything on the unit circle. The radius is 1, and the coordinates on the circle are cosine theta, sine theta. We will mark a few key angles. 30 degrees gives root 3 over 2, 1/2. 45 degrees gives root 2 over 2, root 2 over 2. 60 degrees gives 1/2, root 3 over 2. At 90 degrees, we are at 0, 1. Across the circle at 180 degrees, we are at -1, 0. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.